Cerebral spinal fluid bathes the surface of the central nervous system, and it comes from the ventricles and the choroid plexus. It protects the central nervous system by cushioning the brain, decreasing the pressure on brain structures. It also washes away harmful substances, and it transports hormones to remote areas of the brain. Now, the CSF pressure is greater than blood pressure. This is a good thing because it keeps the direction of fluid flow out of the brain. We don't want the general population in the blood coming across into the brain. And the high pressure within the CSF keeps stuff moving out, not moving in. The peripheral nervous system is made up of the autonomic and the somatic systems. Very briefly, the somatic system is made up of the cranial nerves and the spinal nerves. The cranial nerves, there's 12 pairs. They're listed in your text and what they do. They mediate the peripheral responses originating in the brain. The spinal nerves, there are 31 pairs, each consisting of a sensory or afferent branch and a motor or efferent branch. So we see the sensation is coming into the spine, and then the directions to the body is coming out through the efferent or the motor branch. You get too close to a fire, that heat, that burning sensation comes through the afferent fiber into the spine, where the central nervous system processes it and tells you to move. That's the motor, the efferent message that's coming through. Somatic nervous system spinal nerves is also associated with the dermatomes. That's the areas of the skin that's supplied by the sensory fibers of the spinal nerves. Okay, let's spend a little more time on the autonomic nervous system. Here we have the sympathetic and parasympathetic, and we're going to start with the sympathetic system. It controls how energy is used in stressful situations. And the neurotransmitters here are norepinephrine and epinephrine. Sometimes we use the word adrenergic in association with the sympathetic nervous system. It's the fight or flight system. Norepinephrine affects the central nervous system, specifically increasing the person's attention, making them focus on what is this crisis that's happening, unless the stress is too high and then it kind of overloads and attention is not really good. But in general, it helps the person to focus on what is the danger and what should I do about it. Within the eyes, there's a contraction of the ciliary muscles, which means the eyes dilate. The person can take in more light and more sight and see what's going on better, to process where the danger is. In the blood vessels, there's vasoconstriction, which increases the blood pressure. That means that blood is getting pushed around in the body faster. It's getting up into delivering food and oxygen to the brain and all the other major systems. The heart's doing the same thing by pumping harder and pumping faster. The lungs, the bronchioles, are relaxing. They're dilating to allow oxygen to come in easier and to allow the carbon dioxide that is produced by all the extra physical movement that's going on to be passed out of the body easier. So along with that comes increased sweating. This is a good thing. The body's working harder. We need it not to overheat. So sweat gland secretion increases. Now, the bladder and the GI system are not really necessary in an emergency situation. So the sympathetic nervous system slows it all down. You can't stop to go to the bathroom in the middle of an emergency. So there's decreased bladder tone and constriction of the urinary sphincter. Same thing goes on in the GI tract. Peristalsis slows down, and there's a constriction of the anal sphincter. We don't need to be digesting and passing through waste products. That's not where our energy is needed in a crisis. There's glycogenolysis in the liver, and there's a decreased secretions in the pancreas. All this means there's decreased digestive enzymes and decreased insulin production. So there's more blood sugar left in the blood to be transported to wherever it is needed. So the bottom line here, the sympathetic nervous system keeps the heart working under stress. It gets the blood where it really needs to be in the emergency. It facilitates easy flow of oxygen into the body and carbon dioxide out. It makes energy quickly available to the body. And it slows down all non-essential activities of the body. Now, the parasympathetic system is seen as the opposite. It opposes the sympathetic nervous system. And the main neurotransmitter here is acetylcholine. And the word you hear associated with parasympathetic quite often is cholinergic. This is the rest and digest system. Pupils are constricted. You don't need to see everything anymore. This is a time of peace and calm where you can just rest. The blood pressure comes down because there's vasodilation of the blood vessels. The heart doesn't have to work so hard. So it doesn't beat as hard or as fast. It's not as essential for the oxygen to get in very easily, so there's a relative bronchoconstriction. Remember, this is rest and digest. Now that includes processing the food. So there's increased bladder tone and relaxation of the urinary sphincter, so the body's digesting stuff and getting rid of it. The GI system is doing the same thing. There's increased peristalsis and relaxation of the anal sphincter. There's also gastric secretions are increased. The pancreas secretions are increasing. The digestive enzymes are increasing. The insulin is increasing. There's increased salivation. All of this is meaning that stuff is being digested and stored. It's being stored for future use. There's also increased lacrimation, increased tears in the eyes. Not that that has to do with resting and digesting, but that's part of what's going on. So the bottom line is the body is resting, it's digesting, it's feeding the entire body, all body systems, and it's storing fuel for future needs. There's a general slowdown of all body functions as compared to the sympathetic nervous system.